Hello everyone. Now me and my group members going to do a presentation based on Project 2 for system modeling, simulation and computing subject. I am Dinesh Rao and I am going to explain about the introduction based model analysis and its results. Sing Precision Engineering Center in Berhad producing a compound named A1. To assemble the A1 product, they need four components named X1, X2, X3, and X4. There are two production lines, which is line A and line B. The production line A produce X1 and X2 components, while production line B produce X3 component. The X4 component was supplied by an external vendor. Production line A consists of 5 workstations, which is turning, milling, drilling, grinding, and polishing. The X1 component goes through all the process while X2 component skips the drilling process. For line B, there are 4 workstations, which is bending, drilling, grinding, and control. Every workstation has its own processing time and cost, as we can see from this table. Now, have a look at this base model simulation system. This is the process layout of the system. As I mentioned before, there are two production lines, which is production line A and production line B. The production line B is currently at 50% of defect in its material, which is X3. All the components from the line A and line B is placed in the buffer and transport to the assembly station via the forklift. The forklift in production line A only can transport 20 components in 2 minutes, while for the production line B, the forklift can send 2 components in 12 minutes. All the transported components are placed in the buffer, and lastly, all the X1, X2, X3 components are assembled in the assembly station. The X4 component is directly sent to the assembly station by the supplier. All the components are assembled in the assembly line, and now the assembly station have 5% of defect. So the affected or the defected components are sent to the defect drain, and the non-defective components are sent to the A1 drain. The A1 production runs for 8 days with 2 working shifts, and the total A1 products that produced in 8 days is 355 units. The A1 production company set the target of 500 products. After we run the simulation, it shows that bottleneck in some workstation, like in polishing, bending, assembly station, and drilling. To achieve the 500 product target, we develop 3 alternative models to eliminate these bottlenecks.
Good day to Dr. Azrul and also Dr. Nadia. My name is Chetan. So today I'm going to explain about the alternative model 1 and model 2 for Zinco Precision Engineering Center in Berhad. So the output for simulation model 1 is 519. So the improvement that they've made in this model is adding conveyors to make the product flow in constant speed. And also we have added buffers in line B for each station. Another thing for buffer also we have increased the capacity, and also for line A the processing time also we have changed, like decrease the processing time to make the product process faster. Another thing, we have also made some changes in defects. For control, we have changed the defect rate to 10%. And also for assembly station, the defect rate we have changed to 2%. And we have added the defect for in buffer X1 and also for X2. The percentage of defect is 5%. So now we are going to take a look in utilization chart for alternative model 1. So for alternative model 1, the utilization chart for turning station, the block have been decreased. Same as well for station polishing, the number of utilization is decreased. So these are the causes of increase in the output of this alternative model. As for alternative model 2, we have made some changes, which is in shift calendar, in processing time, and also we have added the number of conveyors in assembly station. So basically, we have doesn't change the capacity for buffer in this alternative model. So the total output for this simulation is 535. Basically, the improvement that we have made is in shift calendar, which is we have made 10 hours for first and second shift. Same as well for alternative model 1. We have also made 10 hours for each shift. And we have also changed the processing time for this alternative also. And then for this alternative model, we have made have added conveyor in assembly and assembly station, and also for buffer at X1, and also for source from X4. Other than that, we have also made defect for line A. For this session is 3%. So these are the improvement that we have made. So now we are going to take a look in utilization chart for this alternative model. Basically, for utilization chart for this model is not as same as the alternative model 1, but there are still the number of block in bending, drilling, and grinding, and also control is in a higher point. So if we take a look in utilization for bottleneck, the polishing is much higher, but in turning, there is the number of block is decreased if compared to base model. So these are the outcome that we have get from the utilization chart according to the output that we have get in this model.
Assalamualaikum and good day. My name is Aiman bin Azri and I will explain about alternative model 3. So basically for the alternative model 3, we duplicate the bottleneck station in line A and we reduce the processing time in assembly station. Other than that, we also put the pallet in line A and line B for transferring the product by using forklift. I will show the simulation of alternative model 3. Now I will run the simulation of alternative model 3. As you can see, the result. As you can see, the result of this simulation is 536. And this is the alternative model 3. After we run the simulation, this is the utilization chart of the alternative model 3. Based on this chart, we can see that polishing, grinding, and milling in production line A are the bottleneck station. So by doing this, we can see that the improvement of workstation produce the product. And then the line B, however, the line B remain the same, but the assembly station showing the increment in working percentage. This is because we improve the productivity of production line A. So it will affect the assembly station working percentage. After that, result comparison between base model and alternative model. For this model, working percentage, we can see that most of the working percentage in base model is higher compared to the alternative model 3. And then the blocking percentage also showing the same result, which is most of the blocking appear in base model is higher compared to the alternative model 3. For weighting percentage, we comparing base model and the alternative model 3, we can see that some of the weighting percentage are higher, some are lower. And then post percentage and unplanned remain the same for both base model and alternative model. For conclusion, we are comparing the total throughput per hour and throughput per day between 3 alternative model. As we can see from the table, alternative 3 are the highest for each type of the throughput. That's all from us. Thank you.